Okay. I wanted to mention for the Anderson students and for you guys, we're not going to form teams across the lines, right? We're going to have teams in New Albany, teams in Anderson. I think it would be too much to ask you guys to interact over long distance. Okay, it's hard enough teaching the course and keeping it all together. We've got 2 inkjet printers we've taken apart and 1 microwave. So whoever took this inkjet printer apart, if you guys can come over and we'll discuss what all we found. I think that was Ply Smith and you're on the team too, right?
Yeah.
Okay, all right. So guys, what did you find?
Found a couple stepper motors. On
Stepper motors?
On this, well,
DC
ribbon.
motors.
Okay, so what are these ribbons? Does anybody know what these are? These ribbons here.
Jeremy, what is it?
It's, those ribbons have fine hash marks that
Right.
operate with a quadrature encoder.
Right, so
Position.
these are called a linear encoder. So
Okay.
if you could look at it close, it really doesn't even take a microscope, but with a microscope you can really see it. Not something high power, but 70 times or something. You can see lines on this. And basically there's a sensor. If you look right here, see that photo sensor? It basically, the lines either block light or allow light through. In fact, there's more than one sensor. What he was talking about with quadrature, I'll tell you more about encoders a little bit later, but basically with quadrature you can tell which direction the carriage is moving. Okay. Anyway, what this does is provide feedback. This is a sensor so that you can detect the position by simply counting how many long lines have gone by as the carriage moves back and forth. We're actually going to use these carcasses in the labs, and you're going to drive these. We're going to use these as a linear motion platform, and you're going to hook up the Arduino and actually drive these things. Okay. What do you think this circuit is for generally? Did you guys decide that?
For
it's okay.
controlling.
Controls how the inkjet is operated.
Right, so that controls the cartridges and makes them fire. Okay, good. And so you said it's a stepper. You meant that this is a DC motor. You can tell that they're using DC motors because this only has 2 wires coming off of it. Stepper motors have more than that, at minimum 4. Some stepper motors have 4, 5, and I think 6. But this is a DC motor. Now, it seems strange because a stepper motor, you'll learn later, you can take to particular positions. It's really easy to command a particular position. Well, the reason they're doing this is because they can get better, faster control with a DC motor. DC motors can actually move faster on average than stepper motors. And if you want your printer to be the latest, greatest printer, you want it to print quickly, right? So you need the ability to move the carriages back and forth across the page very quickly. And that's why so many manufacturers move to using DC motors to drive the carriage back and forth with position feedback. Okay? We're actually going to use that position feedback. And you guys have had controls with me. Did any of you take it when I was still teaching PID control? Anybody remember that? It's been a little while since we've cut that content out of the course. But we're going to learn about PID control, and we're going to use it to control the position of these carriages. That's why I wanted you to all find printers that had this strip in it, because if it's got the strip, it's going to have a DC motor, and we can do PID control really easily. Interestingly enough, the paper feed on this particular printer is also a DC motor with a rotary encoder. If you look at this wheel closely, you'll see a bunch of lines on the outside periphery. And somewhere the sensor has been removed. I don't know what you guys do with the sensors. Oh, it's down here? So it's on this board, so when you assemble this together, however it goes, then that wheel goes down in that slot. And again, you have quadrature, so you can tell which way it's going and get position feedback. Okay, what else did you guys find here?
The DC motor that was in the scan bed.
Okay, this one?
Also has an encoder on the back end of the motor.
Oh, nice, okay. Yeah, good find. Okay, so this wasn't just an inkjet printer, it was a scanner inkjet printer combo. So there's our DC motor, and there is another, you can actually see the lines on this. I don't know if you can see it on the camera, but you can actually see the lines on the encoder. I'll pass this around where you guys can just look at it and see it. And it's easier to understand what the encoder does when you look at this. It's interesting, you don't normally see little motors like this with a shaft coming out both sides. Okay, but servo motors, motors that are used for precision control, do have feedback. It's common to see a shaft coming out the backside on those. I'll pass this around, you guys can look at it. Okay, we started taking apart other printers and found that there were some printers that had only stepper motors, and those are not what we're looking for. We are going to drive stepper motors, so we'll use those. But the goal, of what I really want to get you guys to, is doing PID control with the motor. Anything else we found here? Anything else interesting? Got some components here, capacitors, logic chips.
The dual voltage power supply.
Okay, where did you find that?
The black box.
That's what, 14 and 32-ish?
Yeah.
Okay.
Range.
Well, that's kind of handy. That's nice. I've not seen one like that.
31 volts and 14 and a half.
Okay. So we've got basically our own little standalone power supply we can plug in and get power out of. That is actually kind of sweet. That's
There are
a
a
good
couple
find.
more sensors on the
Okay.
part, like to know whether paper is in place or not.
Okay.
Here,
Okay.
the simple interrupt.
Yeah.
I believe there are two
It's
of
a photo
those.
sensor, isn't it?
Yeah, photosensors are very interesting. Photosensors are actually very similar to how these encoder sensors work. It's just the encoder sensors have two sensors instead of a single photoinductor. Of course, we've got some capacitors, some inductors on the board. Anybody know what this little silver thing is right here?
Clock,
Almost.
crystal.
It's a crystal for the clock.
Yep.
Right. So this is what allows the system to have a pulse, basically, so that when you're dealing with digital logic, you have to do things in steps. You probably are familiar with this with your computer. Your computer runs at 2 gigahertz. Okay, that's the clock speed of your processor. And basically, calculations are done on each clock pulse. Okay, so discrete logic is interesting because technically every circuit is an analog circuit. Really, I mean, there's no real difference between an analog and digital circuit, except that with a digital circuit, what you do is you assume that everything's going to be high or low. Well, when there's changes, when a bit is going from high to low, it actually is in between the two. It changes fast, but there's some time required for the transistors to change state, okay, and for the circuit to settle out to a new state. And so the idea of the clock pulse is that the clock pulses give the circuit long enough to settle down to the next state, so the next calculation can take place and so forth. If that makes sense, great. If it doesn't, don't worry about it too much. It's not all that important. Okay, so of the mechatronic elements, what mechatronic elements do you see here in this printer?
The feedback on position.
Feedback, so we got some sensors. Good. What else? Do you see intelligent control?
Yeah.
So there's microprocessors, probably a microcontroller. Okay. Is this precision mechanical?
Yes.
Yes.
Do you know how finely these things can lay down dots on a piece of paper?
Extremely.
Very fine. We're talking thousands, less than thousandths of an inch sometimes. If you've got a printer that does 1200 DPI, that's finer than 1,000th of an inch dot. Right. So these are precision mechanical systems. You can say, well, really what's going on is the cartridge. Let's see if I can get one out of here. There we go. You can say, well, if you look at the cartridge head, really there's a lot of little holes there, and you drive the ink out of whichever hole you want to make a dot. Well, that's true, but then you have to move the cartridge, right? And you've got to be able to move it within the same resolution that it's printing, otherwise your image is going to be all messed up. So this carriage drive is actually very precise. In fact, these encoders are what are frequently used in milling machines to note position as well. Especially on, I don't know, I've not seen inside a modern CNC unit, but I know when I was dealing with Bridgeport machines, they had a readout for position, which was really nice. You could typically see the encoder on the back of them. They had linear encoders for position feedback. Anything else you guys noted about this? Okay. Well, if you want to pause it, we'll move over to the other